Humanity is astonishing with its capabilities and continues to prove that nothing is impossible for it. It is interesting to find out what lies at the bottom of the ocean and beyond the Earth's atmosphere. We create specialized research devices for this purpose. Space on our home planet is limited, but we can create artificial islands. But what can we do if the population reaches a point where Earth becomes overcrowded for all of us? Of course, we can search for planets with optimal conditions for life in other galaxies, and that seems like the most obvious option. But what if we create our own planets in the habitable zone of our solar system? It may sound too fantastic to some, but science has something to say about this. What would such a system with multiple planets look like? How many objects can it accommodate? Can there be more than one planet on a single orbit? And can all the components of such a system revolve around one central object? Before we delve into discussions about our ideal system with multiple planets, let's talk briefly about the current situation with the solar system. While we know about a vast number of planets outside the solar system, currently around 5,000, within the solar system, there are 8 planets. It's worth noting that our system holds the record for the most planets. We know about the TRAPPIST-1 system, which has 7 planets, and the Kepler-90 system, also with 8 planets. These two systems share other characteristics as well. The more massive planets are located farther from the main star, while the smaller ones are closer. Additionally, both systems have Sun-like main stars. However, there is one important difference in the Kepler-90 system. All the planets are located within 1 astronomical unit from their star, which means they are even closer to their star than Earth is to the Sun. And this is the 3rd planet out of the 8 in total. From this, we conclude that the density in the Kepler-90 system is significantly higher, which means it is possible to create a situation where the distance between planets is smaller than in the solar system. Next, it is important to understand if there is anywhere in the universe a system where there can be more than one planet in the habitable zone. In our planetary system, we have Earth, the only planet with optimal conditions for life during the early stages of the solar system's development. Venus and Mars, which are close to the habitable zone or even within it, could also have been suitable for life. We can take the TRAPPIST-1 system as an example, which contains 3 planets in its habitable zone. Scientists speculate that there may be systems with even 7 planets in the habitable zone. And what about having multiple planets in one orbit? We may not even be limited just 2 planets. There could be more. It is worth noting that 2 Lagrange points, L4 and L5, have a high level of stability in the Sun-Jupiter system. These Lagrange points are occupied by Trojan asteroids, which are located approximately equidistant from the Sun and Jupiter. In theory, not only Trojan asteroids but also Trojan planets could exist, whose positions would practically coincide with these mentioned points. However, such planets have not yet been discovered in the vastness of the universe. We have discussed planets that can form naturally in the universe, but now we will talk about creating systems with the maximum possible number of planets. We can rely on the work of astrophysicist Sean Raymond from the Bordeaux Observatory, who conducted research on this topic. Although his work is not licensed or published in scientific journals, we can extract some relevant information from it. We know that the density of systems similar to the solar system can be an order of magnitude higher. The maximum density value for further discussions will be determined. We will often use the terms sphere or radius in our reasoning. This refers to the space around a celestial body where its gravitational influence dominates. In other words, this space determines the orbits of smaller bodies, despite the influence of a larger object around which the smaller body directly orbits. The Hill sphere is located between the L1 and L2 Lagrange points. For Earth, the value of the Hill sphere reaches 1.5 million kilometers. Since the Moon is about 400,000 kilometers away from its planet, we conclude that Earth's satellite is located within the Hill sphere. The value of the Hill sphere, as we can see, is quite large, and it can accommodate all 8 planets. However, at what distance between planets will the system exhibit stability in terms of interactions between planets? The interaction between planets is strengthened when one enters the Hill sphere of the other, respectively, destructive processes such as collisions can occur between two objects. In the articles by Sean Raymond mentioned earlier, there are studies that state the distance between planets should be equivalent to 5 or 10 Hill spheres. This raises the question of how many planets could potentially fit within the habitable zone of our solar system. It is worth noting that we do not know its exact size. The habitable zone extends from 0.95 to 1.37 astronomical units from the Sun. Taking these calculations into account, Sean Raymond concluded that we could accommodate 6 planets within the habitable zone of our planetary system, where life could potentially exist. So what can we do to increase the number of these planets? It would be ideal to place at least 2 planets on one orbit, with one of them located at either the L4 or L5 Lagrange points. This way, we would have a total of 12 planets, and the system would remain stable. Moving forward, how can we further increase the number of planets based on materials from the journals Celestial Mechanics and Dynamical Astronomy? We conclude that more than 2 planets with equal masses can coexist on a single orbit, provided that the distance between them is at least 12 Hill radii. The minimum number of planets on one orbit would be 7, similar to Earth's orbit. Under such conditions, we could have as many as 42 planets. As we recall, there can be 6 orbits within the habitable zone of the solar system. Could there be such a number of planets on each orbit? The mass of the planets does not significantly affect the distance between orbits. Therefore, if we place 42 planets on 6 orbits, we would have a total of 252 planets with optimal conditions for life. The spacing between orbits largely depends on the influence of one planet, specifically the planet that another planet from a different orbit comes under the influence of. Let's go even further and try to increase the number of planets. Here we need retrograde orbits. In the solar system, planets move along their orbits in one direction. If the distance between planets is relatively small, the planets on different orbits, including gravitationally, influence each other, leading to instability. If 2 planets stay close to each other for an extended period, the consequences can be serious. In such cases, it is better to isolate these 2 planets from each other so they spend less time in close proximity. How can we achieve this? We need these 2 bodies to move in their orbits in opposite directions, resulting in retrograde motion. By doing so, we not only reduce the gravitational influence of some planets on others, but also decrease the distance between the orbits. If we raise the stakes, so to speak, we might be able to form habitable planets outside the habitable zone. Our limit would be 1,000 astronomical units, based on the works of Sean Raymond. This is the optimal distance from the main star, as the external influence on planets will not be significant. Thus, within this zone, we can place 57 rings, each containing 42 habitable planets, resulting in a total of 294 objects. Even though such a quantity may seem incredible and extraordinary, it will not outweigh the total mass of the main star. The Sun will still be orders of magnitude more massive than all the objects in the system combined. Indeed, our reasoning is currently fantastic and purely theoretical. Of course, something like this cannot form in our solar system. However, over time, we may discover planetary systems similar to the ones we described. What do you think? Do you expect such discoveries in the future? And if so, how soon? On Saturn's moon Titan, there are both land and seas, as well as 6 elements that are abundant, so scientists believe that there is a high possibility of life on Titan. Let's take a closer look at the possibility of life on Titan. Titan, a moon of Saturn, is huge, second only to Ganymede in size among moons in the solar system. With a radius of about 2,575 kilometers, it is 1.5 times larger than the Moon and about 40% the size of the Earth. Although it can be observed from Earth, it is difficult to observe Titan's interior properly because of its thick atmosphere. Therefore, Titan was a mysterious celestial body shrouded in mystery for a while. However, in 1997, the European Space Agency and NASA launched the Cassini spacecraft to explore Saturn and its moons, and this spacecraft visited Titan. Hundreds of photos and atmospheric composition analysis were sent to Earth, revealing its identity. The image of Titan sent by the Cassini spacecraft was quite ordinary, with mostly wide plains and sand dunes created by the wind in low-lying areas. There were even mountains as high as 3,330 meters. At first glance, these photos looked like hazy days on Earth with dust or fine dust. Clouds were also observed in the sky of Titan. Weather phenomena occurred on Titan similar to those on Earth, with rain falling and lakes forming on the plains, and even seas forming in low-lying areas. Like Earth, liquid circulation also occurs on Titan. With this information, it seems that the speculations of Professor Carl Sagan, who was always right about the possibility of life on Titan, were not true. Or perhaps humans on Earth will one day be able to live on Titan. Because it is located as far as 1.4 billion kilometers away from the Sun, it doesn't receive enough solar heat properly. So as it turns out, the average temperature of Titan is minus 179 degrees Celsius. Titan can be called a supergiant freezer. Normally, if the temperature is minus 179 degrees, all the clothes on this satellite should freeze. Clouds 3 and oceans confirmed through Cassini-5 have a significant discrepancy with what we usually know. The hills on Titan were formed by completely freezing, and the seas on Titan were made up of methane. Also, the clouds were not white clouds gathered by water vapor like Earth, but had a murky appearance. When we only saw Titan in photos, we thought it could be habitable, but it's definitely not a place with a climate like Earth. Even though our environment is like this, scientists' opinions were very positive when Titan was discovered, except for Earth, as it is the only place where liquid is maintained on the surface in a stable way. This is the first celestial body that we confirmed, and there might be life forms here. Also, thanks to the layered structure of Titan, there are winds and rain, making it an optimal place for life. Now let's take a closer look at Titan. Titan has a dense, murky atmosphere. The atmospheric pressure is about 1.45 times that of Earth, and about 98% of the atmosphere is made up of nitrogen with trace amounts of methane. Interestingly, aside from Earth, Titan is the only celestial body in the solar system with nitrogen. Scientists say that Titan's nitrogen-rich atmosphere is very similar to the primitive atmosphere of Earth about 3.8 billion years ago. If we can analyze Titan's atmosphere, we can learn more about the changes in Earth's atmosphere. Currently, nitrogen is the most abundant gas in Earth's atmosphere, accounting for 78%, followed by oxygen at 21% and argon at 0.90%. These atmospheric compositions are present on Earth. However, these ratios have changed slightly over the course of several hundred million to billions of years. Titan's dense nitrogen atmosphere causes a greenhouse effect, which maintains a high temperature despite receiving very little solar radiation. This keeps methane in a liquid and gaseous state. If Titan did not have nitrogen, all of its methane would have frozen, and Titan itself would have become a completely frozen celestial body. Amazingly, the study of Titan has even led to the discovery of some unique molecules that are essential for life formation, such as cyclopropanyl, which is composed of carbon and 2 hydrogen atoms. This molecule is an important building block for life and also serves as food for other organisms. Although cyclopropanyl is difficult to pronounce and understand, it is a crucial substance that cannot be overlooked in the formation of life in the universe, and has been observed occasionally in interstellar matter. However, except for Titan, there has been no discovery of such compounds in other celestial bodies, so it's really amazing and remarkable. Cyclopropanyl, composed of 2 carbon atoms and 2 hydrogen atoms, has been discovered in Titan's atmosphere using the ALMA radio telescope by NASA's research team. The discovery of this molecule, which is difficult to pronounce and has caused quite a stir, is an essential component of the formation of living organisms and can also serve as food for other organisms. Although it has occasionally been observed among interstellar substances in the universe, it has never been found in any other celestial body until now, except for Titan. This is really remarkable, especially considering that it has only been found in 2 places, Titan, which is similar to the primitive Earth environment, and some other celestial body. Moreover, many benzene compounds have also been detected. These compounds play a role in the formation of complex organic matter. In addition, there are other compounds such as argon and carbon monoxide in the atmosphere of Titan, which is conducive to the formation of organic matter during its evolution. It is an environment where organic matter formed during its evolution is falling like light snow. There is one more fact to note about Titan. It is that 82% of its surface is covered with organic matter. According to Dr. Rosalie Lopez, a NASA scientist, more than 82% of Titan's surface is composed of organic matter that has fallen from its atmosphere and has been transported by winds. This means that Titan's organic matter is very abundant, which suggests the possibility of the existence of living organisms. This is an exciting discovery that raises the possibility of the existence of microbial or other life forms. If such life forms were present, there would be abundant sources of food. Another important fact is that there are oceans on Titan. Prior to this, lakes were discovered on Titan, but now it has been revealed that there are oceans as well. If the liquid in these oceans seeps into the subsurface, it could provide sufficient conditions for the birth of life. While this liquid is not water, Titan is the only celestial body in our solar system, besides Earth, where liquid exists on the surface. Scientists have found that Titan's oceans are deeper than previously thought. In fact, during an investigation of one of Titan's seas, Kraken Mare, the equipment that was used to probe the sea was limited by its technological capabilities and was unable to reach the bottom, which is at least 300 meters deep. This is more than 7 times deeper than the average depth of the West Sea, which is approximately 43 meters. In addition, there are geological activities like volcanic activities in Titan, and if such visual activities occur, an ecosystem ranging from microorganisms that use organic matter around the hot springs as food to predators on top of them may have formed. From the beginning, including Titan, organic matter is very abundant, so if miraculously some organisms were discovered on Titan, an ecosystem of organisms and their mothers could have already formed in Titan's seas. The most important clue is this. Recently, it was found that after hydrogen descends from Titan's atmosphere, it disappears from the surface, according to the data collected by Cassini. Some scientists at JPL are claiming that this may be the result of primitive life breathing in and consuming material on the surface. However, Titan's flowing liquid is methane, so if life is actually emerging and surviving here on Titan, the living organisms of Titan may be based on methane. Scientists are looking at Titan's existence of life with a very positive outlook. NASA has started the Dragonfly project to explore the seas of Titan. They will fly a kind of drone powered by a blue-tone fuel to observe various terrains of Titan. The Dragonfly project is expected to launch in 2026 and arrive near Saturn in 2034. They plan to use a parachute to land on Titan when the weather is favorable, and then switch to flight mode to explore and collect samples. Previously, Genius explorations were mostly conducted using ground vehicles, but this method had limitations in mobility, so the goal is to easily explore multiple locations. I will go crazy with my child's drone to explore. The target distance and time for the exploration are about 2 years, 7 months, and approximately 175 kilometers. This distance is twice the distance traveled by all Mars rovers so far. NASA hasn't made a final decision yet, but they say they could send a 1-ton submarine to Titan. The purpose would be to explore the largest Kraken Mare Sea on Titan, which has a fairly deep depth from the beginning. A submarine would be 10 times better than a drone to explore it. If we explore the liquid methane ocean with a submarine, we could thoroughly examine the ocean floor. What do you think about the possibility of life on Titan, Saturn's moon? Imagine a stationary world, ancient, about 4.5 billion years old. It is barely warmed by the sun's rays and covered with a thick layer of ice. This world is smaller than our moon, but slightly larger than Pluto. Its name is Europa, the 6th moon of Jupiter, and one of the largest satellites in the solar system. But what is most interesting about this distant place is that it may harbor life, according to astronomers. Europa is considered one of the most promising places in the solar system to search for new forms of life, all because it has a vast ocean of salty water, ranging in depth from 60 to 160 kilometers. It is hidden beneath a layer of ice with a thickness of 16 to 30 kilometers, but it is still potentially suitable for life. Astronomers claim that water erupts from cracks in the icy crust and is ejected, making it potentially suitable for life. Of course, reaching such a deep environment will not be easy for missions. On the other hand, scientists already have evidence that there are much smaller bodies of water, likely located much closer to the surface of the Moon. They could be situated less than a kilometer beneath the ice. This news brings two positive aspects. Firstly, it increases the chances of life existing on Europa, and secondly, if true, it will make it easier for future missions to search for these life forms. The lead researcher, Riley Kohlberg, accidentally came across a presentation by a colleague who showed a photograph of double ridges on the surface of Europa. Kohlberg remembered seeing similar ridges on Earth, although they are rare on our planet. However, on Europa, they are much more abundant. Subsequent research allowed them to hypothesize that the ridges on Jupiter's moon may be the result of a specific cycle, similar to what occurs on Earth. In this cycle, liquid water freezes and then thaws inside the icy crust, which represents an environment with relatively high pressure. This causes the icy crust to move upwards, creating a two-ridge structure. At least, this is how it happens on Earth. If similar processes exist on Europa, it could indicate the presence of subsurface water. However, the temperature, pressure, and chemical composition on Europa are entirely different, and scientists still don't know how the ice behaves there. Therefore, they cannot understand the depth or size of the water pockets or the time required for freezing. However, it is clear that such a subsurface environment on Europa is likely protected from harsh radiation from Jupiter, which bombards the Moon's surface. This, in turn, increases the chances of life existing in Europa's subsurface. Now we can return to the fact that the ocean on Europa appears to be salty. The red streaks on the Moon's surface may have that color due to their chemical composition. Most likely, they represent a frozen mixture of water and salts. This is quite unusual because this composition does not correspond to any known substance here on Earth. As for the yellow patches on Europa's surface, they may be caused by the presence of sodium chloride. This substance is known to us as salt. Scientists have tried to recreate the conditions on Europa in the laboratory and found that by combining water, table salt, low temperatures, and high pressure, they could obtain a new form of solid crystals. This substance can exist both at the bottom of Europa's ocean and on its surface. However, apart from this information, researchers haven't been able to learn much more. We can only hope that we will find answers to some of these questions around 2030. It is around that time when the Europa Clipper mission, planned by NASA, may reach Europa. The mission plans to conduct several close flybys to determine whether there could be any form of life there in the next couple of years. Europa will be visited by a spacecraft from the European Space Agency. However, Europa is not the only place in the solar system where life may exist or have existed. On our planet, a large portion of this gas in the atmosphere is produced by living organisms, such as methane generated by digestive processes in animals. Scientists believe that methane existed in the Martian atmosphere for about 300 years, but in 2006 it nearly disappeared, about 600 times faster than researchers had anticipated. The question remains, what or who produced this gas, and where did it go? Another Martian mystery involves microbes that may be dormant beneath the surface of Mars. They could have sought refuge from cosmic radiation for millions of years. Scientists simulated conditions on Mars in laboratories to test whether this could be true, and they were amazed to discover that bacteria easily survived in such conditions for 280 million years. This means that if life existed on Mars, we could find evidence of it. Currently, Mars lacks flowing water, and cells or spores would simply dry out. Additionally, the surface temperature is similar to that of dry ice. In other words, the surface is extremely inhospitable. The most likely candidates for life on Mars, if any, are bacteria-like organisms nicknamed Conan due to their rugged nature. Now let's move on to Venus. In 2020, scientists announced that something was found in its toxic atmosphere that could indicate the presence of life. Unfortunately, there was no direct evidence, as there was no opportunity to collect microbial samples or capture images of extraterrestrial life. However, they claimed to have detected a chemical substance called phosphine on Venus, which is highly significant. If this gas is not formed as a result of previously unknown chemical processes, then some microbial life may be involved. Phosphine consists of 3 hydrogen atoms and 1 phosphorus atom. This gas is toxic to any terrestrial life form that requires oxygen, including us humans on our planet. Phosphine can be found in places where there is little or no oxygen, such as swamps and marshes. It is formed as a result of complex mixtures of bacteria living there. It can also be produced industrially. If we think about it, phosphine should not be present in the atmosphere of Venus at all. The formation of this gas requires specific pressure, temperature, and tons of hydrogen. It would not be surprising to find it on Saturn or Jupiter, known gas giants. On this planet, phosphine cannot form naturally, or rather, it may form in small quantities during volcanic eruptions, storms, explosions of minerals on the surface, or when meteorites enter the atmosphere. However, there cannot be as much phosphine as astronomers have calculated, and this should have raised suspicions among scientists. But they were too delighted with their discovery. Perhaps they believe that life may exist on Venus. However, even if this gas was created by some mysterious organisms, it remains a big question how they survived on Venus. On our planet, some microbes can thrive in an environment with only 5% acidity, but not more. However, Venus clouds are composed mostly of acid, with over 90% sulfuric acid. Moreover, the atmosphere of Venus is 50 times drier than the driest place on our home planet. In fact, in 2022, thanks to high-resolution telescopes, it was concluded that there is only a very small amount of phosphine in Venus' atmosphere. So we need to look for signs. Jupiter is enormous. It could fit 1,300 Earths inside it. It's extremely hot here, with the planet's core temperature reaching almost 24,000 degrees. Unfortunately, we can't land on Jupiter. It's a gas giant with no solid surface, but it is possible to descend deeper into Jupiter's atmosphere. Look at those dense brown, yellow, red, and white clouds. It's because of them that the planet appears so colorful and striped. If we descend to the planet's center, we can see how its atmosphere, composed of hydrogen and helium gas, turns into a liquid, all thanks to the immense atmospheric pressure around Jupiter's core. There are many mysteries swirling around. Scientists have not yet determined whether it is a molten sphere, a dense liquid, or a solid rock. It is 14 to 18 times larger than Earth, regardless. In any case, the main goal of our journey is not to explore Jupiter. We came here to see the Great Red Spot, a massive atmospheric vortex raging in the planet's southern hemisphere. It is nearly 8 kilometers taller than the surrounding clouds and almost 1.5 times wider than our planet. In 2017, space probes such as Voyager and Juno gathered a lot of information about the Great Red Spot. It turns out to be a monstrous storm that extends 322 kilometers deep into the planet's atmosphere, which is 30 to 100 times deeper than any ocean on Earth. However, these data might be imprecise, and the origins of the vortex could be even deeper. The Great Red Spot is colder than the rest of the atmosphere. The temperature on Jupiter's upper cloud layers is minus 148 degrees Celsius. On the other hand, the closer to the core, the hotter it gets. It is strange that the high temperatures observed on Jupiter were registered in the atmosphere directly above the Great Red Spot. There, the temperature reached 1,300 degrees Celsius, higher than the temperature of lava on our planet. Astronomers believe that turbulence caused by the vortex can lead to gravitational and sound waves, which may be the cause of overheating. However, at the bottom of the vortex, it is warmer than at the top. People have been observing the vortex on Jupiter for over 150 years. Astronomers once predicted that it would gradually slow down, shrink, or disappear completely, but that turned out not to be the case. After analyzing all the data obtained with the help of the Hubble Space Telescope, scientists were perplexed when they discovered that the winds at the outer boundaries of the vortex gained speed. The changes amounted to no more than 2.5 kilometers per hour over the course of one Earth year. which is very small. However, despite this, it still holds great significance. The wind speed at the edges of the vortex can reach an incredible 645 kilometers per hour, faster than a tornado on Earth. But it turns out that if you were in the center of the Great Red Spot, the spectacle would not impress you because the wind speed there is much lower. Scientists faced numerous challenges when trying to unravel the mystery of the Great Red Spot. It is unknown what fuels this vortex. It may be something within the planet itself. Being a gas giant, Jupiter lacks a solid surface, so there is no friction, the only phenomenon capable of weakening the vortex. The hot gases in the planet's atmosphere are constantly in motion, rising, descending, and swirling, similar to Earth where colder and warmer air masses mix and merge, forming giant storms. Astronomers believe that at some point, several massive storms could have merged to create the Great Red Spot, and now it constantly absorbs cold gases from below and hot gases from above. Furthermore, the vortex can absorb smaller vortices, making the Great Red Spot even stronger. Unfortunately, due to the dense clouds on Jupiter, astronomers cannot see what is happening in the lower layers of the planet's atmosphere. Scientists have long pondered what might be hiding beneath the Great Red Spot. A massive volcano is unlikely, as Jupiter is primarily composed of gases and lacks a crust that could crack, allowing lava to erupt. There are several theories about why the vortex has such a color range. It varies from whitish and pale pink to bright orange and brick red. Scientists believe that the answer lies deep beneath the Great Red Spot, closer to the planet's surface. A colorless layer of gas can likely react to ultraviolet radiation from the sun, resulting in a red color. However, this is currently just a theory. Hey, you've also thought about it, right? Jupiter isn't the only star with a giant vortex. Another one, the size of our Earth, is raging on Saturn, and it's called the Great White Spot. How original. Vortices have a tail of white clouds surrounding the entire planet. This phenomenon occurs approximately every 30 years. This vortex actually starts as a spot, but then it expands more and more. Astronomers have discovered that the Great White Spot is a massive thunderstorm system. The size of the storm can produce lightning flashes more than 10 times per second. But the main mystery of the Great White Spot lies in its energy source. Some scientists believe it can draw energy from the sun, while others claim that the structure of the thunderclouds only makes sense if there is an internal heat source powering the winds. Nevertheless, powerful vortices exist on different planets in the solar system, and ours is not the only one. Let's move to Pluto, the largest of the known dwarf planets in the solar system, and explore its atmosphere. It extends high above the planet's surface and contains more than 20 layers of icy formations. By the way, the Moon also has an atmosphere called the exosphere, composed of helium, neon, and argon. It is about 10 trillion times thinner than Earth's atmosphere. A black hole is a place where gravity is so strong that even light cannot escape. However, sometimes they can behave like enormous galactic volcanoes. Black holes can ignite like volcanoes, but instead of spewing lava, they generate an enormous amount of energy. As a result, they leave behind huge voids in the surrounding gas and material. Recently, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that ignited many, many years ago. This event occurred in a galaxy cluster located approximately 390 million light-years away from Earth. The remaining crater can accommodate 15 Milky Way galaxies. It's hard to believe such a thing. During space travel, think twice before landing on unknown planets, or else you might find yourself in a place like Kepler 141b. This planet is outside our solar system, and at first glance it doesn't differ much from Earth. There are liquid oceans that evaporate, forming clouds instead of condensing. On this planet, rain falls not from water but from stones. The surface of this exoplanet is covered with lava seas that reach depths of tens of kilometers. During the day, the temperature on 141b reaches nearly 28 degrees Celsius, which is enough for the magma in the oceans to evaporate into the atmosphere. Then, supersonic winds with speeds of up to 1.5 kilometers per second transport the vaporized rock to the planet's night side. The evaporated magma cools down, turns liquid again, and falls as a stone rain. Sometimes it seems that our planet is huge, and we are just tiny particles, mere specks against its colossal dimensions. Indeed, in the scale of the universe, Earth appears to be a giant, but it is actually insignificant and small. In our videos, we often talk about distant galaxies and the edge of the universe to understand the place our planet occupies in this world. However, what if we take a journey not billions of light years away, as we have become accustomed to, but instead stay within the confines of our solar system? It might seem boring, but there is still much we don't know about the planets we were taught about in school and the countries whose names we heard. Leave your earthly problems behind and look at the night sky, where the moon stands out prominently. The moon, an unchanging natural satellite of Earth, has been visited by 12 American astronauts. The first, as you know, was Neil Armstrong, who set foot on the moon in 1969. The last person to set foot on the moon was Harrison Schmitt in 1972. 51 years have passed since then. However, despite that, the moon remembers everything. It is distant from the Earth at a distance of 384,400 kilometers, but in the scale of the universe, it is not such a great distance. However, in human perception, this journey appears to be very, very long. It is quite possible that a new journey to the moon will happen very soon. In May 2024, a manned lunar flyby is planned as part of the Artemis II mission, and in 2025, there are plans to land humans on its surface during the Artemis III mission. Who knows, perhaps after that, we will look at the moon with a completely different perspective. Let's fly away from Earth a little further. There is something more interesting waiting for us there. Venus, the planet named after the Roman goddess of beauty, truly mesmerizes with its hostile and deadly beauty. Due to its reflecting sunlight clouds, it is also the brightest planet in our solar system, so it is impossible not to notice it. It has several names: the morning star, the evening star, and the evil twin of Earth. But why the evil twin? Judge for yourself, as the sizes of both planets are indeed similar. However, while Earth is a comfortable planet for life, Venus, on the contrary, is harsh. The atmospheric layer of Venus is dominated by carbon dioxide gas, and the clouds, which could be mistaken for earthly ones, are made of sulfuric acid. Life forms as we know them wouldn't survive. And that's not the only reason why Venus can be considered an absolute hell. It's incredibly hot on Venus, somewhere around 500 degrees Celsius. Not a pleasant temperature, I must say. And of course, if we were to land on the surface of Venus, we would simply turn into a pancake. It's all due to the deadly gravity for human beings. Truly, it is the evil twin of Earth, deadly beautiful. Global warming here is without exaggeration taken to the extreme. It's quite likely that things were not always like this, and Venus was not as menacing. There is a theory that over time, Earth may end up looking the same, with a threatening atmosphere. Who knows, perhaps everything is indeed like that. And maybe a different fate awaits Earth, similar to Venus. Closest to the Sun is Mercury, and it is also an extremely inhospitable planet. During the day, the temperature there is around 430 degrees Celsius. At night, it drops to 190 degrees, horrifying temperature fluctuations. The terrain of Mercury is characterized by numerous irregularities, which indicate the turbulent times it has endured. For its size, the planet is quite massive, and its gravitational force is truly enormous. Perhaps at some point, the planet was larger, but due to a collision with another planet during its early stages of existence, it reduced in size. Who knows, if that hadn't happened, Mercury could look completely different now. Yes, the cosmos is cruel, and not everyone is destined to remain intact or even survive. Our main star, the Sun, the source of life and death. It is just as deadly in its magnificence as Venus. Thanks to the Sun, life exists on our planet. However, it can also destroy us. Our ancestors were aware of the tremendous power of the Sun and its influence on us. That's why in ancient beliefs, there was always a sun god, such as Helios in ancient Greece or Ra in ancient Egypt. The Incas worshipped the sun, and the Aztecs feared it. If, for example, we didn't know how to pay tribute to the sun for just 10 minutes, which is lethally hot on its surface, the temperature reaches 572 Kelvin. In the inner layers, it's even orders of magnitude higher, and it's terrifying to imagine that figure. Just imagine the power of the nuclear reactions happening there, when you go out to bask in the sun on a spring day. Remember how deadly the sun is and how many nuclear reactions are occurring on it at that very moment. Prominences, which are loops that form above the surface, are held in place by the sun's magnetic field. Even 10 million volcanoes would barely produce as much energy as a single one of those loops generates. Sunspots also form there, and they stand out due to their black color. Their temperature is an order of magnitude lower than the surrounding areas. However, the sun has great power, but nothing lasts forever, and our main star is no exception. Sooner or later, the sun will reach its point of slow fading and perish. And that means the same fate awaits our home planet, and we will continue to acquaint you with these facts. Humanity is not only interested in what will happen in the future, but also in what has happened in the past. Take comets, for example. They also carry tremendous power within them. Our planet has not encountered comets on its path for a long time. However, according to some specialists, one of them could have collided with the Earth and contributed to the emergence of life by providing us with water. And that's precisely why Earth could have become the way we know it now. This allowed the human race to come into existence. But imagine what would have happened if a comet collided with our planet now. It would mean the end of humanity, at least on Earth. Perhaps, if such an event occurred, some people would start searching for a new home on another planet, topped in giant space arcs like in science fiction novels. But for now, we haven't ventured beyond the solar system. We're heading towards Mars, the red planet. Attempts to find even traces of living organisms there started a long time ago. Mars has always captivated people's imagination. Just think of the countless works of science fiction dedicated to Martians and the possibility of life on Mars. This theme has intrigued visionaries like H.G. Wells long before the first satellite was launched into Earth's orbit. But what if all these stories carry at least a fraction of truth? Would we be able to accept such information? This question for now remains unanswered. Mars holds a vast amount of fossils, and there are powerful sandstorms occurring there. Mars has an atmosphere, although it is too thin. Carbon dioxide dominates its composition. It wouldn't be easy for a living organism to survive there, to say the least. Additionally, the surface temperature drops to -60 degrees Celsius. However, of course, there are creatures that can survive in very harsh conditions. In theory, they could potentially live on Mars. But there are some nuances. There needs to be geological activity to produce various essential substances. We should continue exploring Mars more and more actively. Then we will know more about its past, present, and future. The Opportunity rover, one of the two rovers, took on the task of studying the planet's surface. As part of the Mars Exploration Rover project, NASA has embarked on surface exploration. Many of the plains we see on the surface could have been Martian lakes. Furthermore, there is a hypothesis that water flows in the planet's subsurface layers. Perhaps there was life on Mars in the past. Can you imagine? You'll be even more surprised. After all, there is a theory that Mars gave life to Earth. It is suggested that at some point there was a collision between Mars and some object, possibly an asteroid, which resulted in a piece separating from Mars. Martian microorganisms remained on that fragment. Later, this part fell to Earth along with everything else, which gave rise to the emergence of life on our planet. Oh, there is still so much we don't know about Mars. During our journey to the next planet, we encounter difficulties, namely with asteroids. Their speed usually reaches 80,000 kilometers per hour, and their width can reach hundreds of kilometers in earlier periods. As a result of collisions, fragments of asteroids would break off, and some of them would later become planets, which laid the foundation for our planetary system. For example, we have learned that the age of Earth is approximately 4.5 billion years by studying the remnants of meteorites on the surface of our planet. However, some fragments of asteroids did not become planets. They encountered insurmountable barriers along their way. Jupiter, a giant planet, compared to it, Earth appears to be just a small sphere. Multiple Earths could fit inside Jupiter. Due to its size, the gravitational force of the giant planet is very powerful. Under the gravity of Jupiter, asteroids that enter its zone of influence cannot transform into planets. It is also called a gas giant. and it's not without reason, as gas predominantly makes up its composition. So if we were to land on the planet's surface, we would see firsthand that its upper layers are quite soft, and we could easily sink into them. Furthermore, Jupiter, like its counterparts in the planetary system, is mesmerizingly beautiful, and this beauty is also deadly to all living things on the gas giant. There are very strong winds that race across its surface at tremendous speeds, resulting in the formation of various whirls and vortices, which can be observed in Jupiter's images. The most notable of them is the Great Red Spot, which is approximately 300 years old and is 3 times larger than Earth in size. Can you imagine that? Jupiter is a deadly planet where, in addition to everything else, there are incredibly high levels of radiation. The amount of radiation it possesses attracts the strongest magnetic field to the planet. Indeed, it is better to admire such beauty from a distance, as it is unlikely that any force could calm down this majestic planet. As you can see, we have ventured not far from Earth, and how breathtaking discoveries we have made. We certainly know that this is far from everything the solar system has to tell us. And what do you think it will reveal to us someday about the history of the universe? Will it share the secrets of extraterrestrial life? Which fact has been the most interesting to you? And what did you already know about the history of our solar system? Just imagine an endless plain, and there's a descent covered by waves of an eternally restless sea. To all this, add extreme pressure levels and immensely powerful winds. The sky is completely covered by a dense blanket of clouds, and only in the distance does a red sun peek out on the horizon, just for a moment, before hiding behind the clouds. Now, you can barely see it. The sun doesn't actually change its position, but that didn't stop it from disappearing from our view. Look around. It seems like the last place where any living organism could exist. However, it's not that simple and straightforward. We have just described to you how the so-called second Earth on this planet could look like. Researchers may also start searching for extraterrestrial life forms. So what kind of astonishing planet is this? We're sure that after watching our videos, you might have had the desire to work in the field of space exploration. However, remember that there's plenty of work to be done on Earth as well. As you know, in the last decade, scientists have discovered a huge number of exoplanets. Currently, there are 4,370 of these objects, located in approximately 3,230 planetary systems. Among them, around 3,000 planets are in the confirmation stage of being exoplanets. Typically, these objects are of enormous size, including gas giants, super-Earths, and super-Jupiters. Technical exoplanets are large bodies that orbit their stars in a relatively short period of time, making them much easier to detect than smaller planets. Exoplanets can amaze us not only with their sizes, but also with the possibility of hosting living organisms. The number of candidates in this regard is in the dozens, and they become a piece of home for researchers. Among such exoplanets, GJ 832c stands out. It is located in the constellation of Grus, and scientists believe that it has the highest probability of hosting life among all known exoplanets. The main star around which this object orbits is named Gliese 832. The distance between it and our Sun is approximately 16 light-years. Gliese 832 is a relatively dim, red-colored object with a luminosity of about 0.7% of the Sun's luminosity. The mass and diameter of the star are approximately 50% of the Sun's respective values. The temperature on Gliese 832 is around 326 degrees Celsius. Due to this, the habitable zone around the star is quite narrow. Objects within this zone will experience tidal locking, meaning they will always have one side facing the star. The most famous example of tidal locking is the Moon and Earth. It is known that there are 2 planets in the habitable zone of Gliese 832. One of them is Gliese 832b, discovered in 2008, which has characteristics similar to Jupiter. Its mass is about 2/3 of Jupiter's mass. The distance between Gliese 832b and its star is approximately 3.4 astronomical units. In 2015, a second planet, Gliese 832c, with an Earth similarity index of 0.81, was discovered. This is considered a high value and didn't go unnoticed by the global scientific community and, of course, sensation-seeking journalists. As a result, Gliese 832c acquired another name, Second Earth. However, despite these two planets sharing similarities, there are many differences between them. Nevertheless, the Earth Similarity Index of Gliese 832c is very high, and its mass is equivalent to 5.5 times that of Earth. The orbital period around the main star, Gliese 832c, is 35 Earth days. The distance between the star and the exoplanet is 0.16 astronomical units. It's worth noting that the distance from Earth to the Sun is defined as 1 astronomical unit. One peculiar feature of Gliese 832c is that due to its relatively wide orbit, it may occasionally leave the habitable zone. As a result, rapid temperature fluctuations are characteristic of this exoplanet. The amount of energy that Gliese 832 provides to the exoplanet is essentially equivalent to the amount of solar energy that Earth receives. The temperature on the planet itself reaches -20 degrees Celsius. It is assumed that the atmosphere of Gliese 832c has a relatively high density, which can increase temperature levels. We have already mentioned the high probability of the exoplanet being in tidal locking with its star. Additionally, its habitable zone is relatively narrow, indicating a small distance between Gliese 832c and its star. Since exoplanets are always tidally locked to their main star, there are significant temperature variations between the illuminated and unilluminated sides. If the atmosphere's density is sufficiently high, storms can occur on Gliese 832c. In the Gliese 832 system, there may actually be not 2 but 3 planets. Scientists from the University of Texas at Arlington concluded this in 2017. The estimated size of the presumed third planet is approximately 10 to 15 times the mass of Earth. It is located at a distance of 0.25 to 2 astronomical units from its main star. The existence of the third planet has not been confirmed yet, as more data is needed. However, let's return to Gliese 832c. Let's imagine how this exoplanet would look if it had living organisms. The gravity level on Gliese 832c should be noticeably higher than on our planet. We don't know the exact diameter of the planet, so we cannot determine its gravity precisely. However, we do know that the density of Gliese 832c is similar to that of Earth, so its gravity could be approximately 3 times that of Earth. These measurements would contribute to the formation of a more even relief and the depth of oceans on Gliese 832c. These conditions can be considered favorable for the emergence of living organisms, as there will be more areas where potentially warm water can exist. Regarding the appearance of Gliese 832c, the most likely scenario is that the relief formations will be of a reddish color. This is due to the dim light and high atmospheric density. Because the exoplanet is in tidal locking, the unilluminated side will have high temperatures, while the illuminated side will have lower temperatures. There will be a ring-like region where the illuminated side transitions to the unilluminated side, and this area will have the most favorable temperature for the development of living organisms. Precipitation in the form of liquid water will be abundant at the boundary with the dark side, where glaciers would melt. As a result, the amount of water would increase. However, a significant drawback in this case would be the incredibly strong winds caused by temperature differences. These winds could be restrained by high mountain formations. However, due to the gravitational forces, these mountains would not be of sufficient height for that purpose. The exoplanet moves in an elongated orbit, but it is relatively small due to its close proximity to its main star. As a result, the change of seasons occurs approximately once a week when the exoplanet is closest to or farthest from its star. When it is closest, summer arrives, and when it is farthest, winter comes. The inclination of the planet will not play a significant role. It is the distance between Gliese 832c and its star that determines the seasons. It is presumed that in the ring-like region of the exoplanet, the change of seasons will have a similar effect as tidal forces on Earth, causing tides and periodic flooding of certain areas, followed by water receding. During these processes, particles of different substances enter the water, creating an ideal environment for the development of living organisms. Scientists suggest that life on Gliese 832c may thrive exclusively in a watery environment. The effects of gravity and temperature variations in the ocean are significantly reduced. Potential living organisms could adapt to frequent changes of seasons by migrating to more comfortable areas or entering a state of dormancy, making harsh conditions less of a concern for them. Now let's imagine how these living organisms, if they ever appear on Glacier 832c or have already started to appear, would look like. Plants, most likely, would resemble mosses and have a dark color to maximize their solar energy absorption. To withstand strong winds, they would need sturdy roots. Due to the high atmospheric density, there could be atypical forms of organisms that develop directly in the atmosphere rather than on the surface. They would move with the direction of the wind and extract necessary substances from the air for their vital processes. Scientists studying space believe that there must be life forms somewhere other than Earth. With the era of space exploration in full swing, humanity is searching for traces of life within our solar system. Among the many planets, the most likely place to find life is Mars. So why do scientists believe that there is a high possibility of life on Mars? In the late 19th century, astronomers observed Mars through telescopes and discovered that it rotates on its axis and its tilt is similar to Earth's. They also observed that Mars had seasons, which indicated that Mars has an atmosphere similar to Earth. These observations suggested that Mars is like a second Earth with its own unique features. In addition, in 1877, Mars moons Phobos and Deimos were discovered, further increasing interest in Mars. Since then, scientists have continued to observe Mars and have found evidence of water on its surface, leading to the possibility of the existence of life on the planet. I discovered that some areas of the surface were bright, while others were dark, and at the time, scholars believed these to be continents. They also thought that Mars had a dense atmosphere, and when they continued to observe Mars, they believed that the changing colors on the surface were due to the seasonal changes of plants on Mars. In October 1895, the American astronomer Percival Lowell made the following claim. "Through my telescope, I have watched Mars for a long time, and I am sure that there are canals made by Martians, and on the planet there is a civilization, and Martians live in society." In the 18th century and early 19th century, scientists had debated whether or not there was evidence of life on Mars. However, as humanity's space technology rapidly advanced, some scientists began to argue that we should go to Mars to find out firsthand. The first country to attempt to explore Mars was the Soviet Union in the 1960s, but they experienced many failures. Starting from the atmosphere, now the US is starting its exploration of Mars. Oh, the Thomas exploration is not an easy task. Oh, it's not some cheesy talk on a Friday night. But we're talking about the only light Unyum king out there. Should we book a cell and go to Mars first? Although the Soviet Union started exploring Mars 4 years before the US did, the US was the first to achieve results. In 1965, the US's Mariner 4 became the first spacecraft to approach Mars closely and send back images to Earth. The photos taken at that time totaled 22, but since it was an era of black and white photography, the image quality was not very good. Then, in November 1971, the US's Mariner 9 became the first spacecraft to successfully enter Mars orbit and sent back an enormous amount of data to Earth, including only 9 photos out of 7,300 taken, capturing about 80% of the Martian surface. The photos taken are diverse, including impact craters, the largest volcano in the solar system, Olympus Mons, and the erosion and deposition that occurred, almost showing the entire Martian surface. During this time, the Soviet Union was also tirelessly pursuing Mars exploration, but they didn't achieve significant results. Now, the United States, with billions of dollars, is embarking on the ambitious Viking project, focused on searching for extraterrestrial life. After the successful landing in 1980, Mars became a utopia. They successfully landed on the plains and immediately transmitted nearly 16,000 images back to Earth. In 1976, Viking 1 and Viking 2 successfully landed on Mars. After landing, they began searching for signs of life on Mars. They collected samples from the Martian surface and analyzed the atmosphere, but they couldn't find any trace of organic matter. However, the Viking lander had a fatal problem of being unable to move after landing. With all the exploration they're doing on Mars, it seems like they won't be satisfied with just one purpose. For the Mars exploration, NASA sent a rover with 6 wheels to actively explore various places. That's how the Mars Pathfinder was launched, with the intention of exploring multiple locations. The Pathfinder landed on Mars in July 1997. The Sojourner rover traveled around various locations on Mars for about 3 months, researching the atmosphere, soil, and rocks in search of life forms. However, once again, they did not find any friends of any life forms. Nevertheless, there were still significant achievements. It was revealed that the Homestake event occurred about 3 million years ago, causing erosion that created the Ares Vallis. This means that our existence on Mars had an impact. After the success of the Mars Pathfinder, humanity continued to send exploration missions to Mars. The goal is to explore Mars itself or find evidence of water or life on Mars. First, Mars Odyssey found evidence of water and ice on the surface of Mars from orbit. In 2003, the European Space Agency's Mars Express mission discovered water molecules at the south pole of Mars and succeeded in capturing images of ice. In 2008, NASA's Phoenix mission landed at the Martian North Pole, where it found water and ice and collected samples from the surface. The purpose of studying these Martian samples is to determine whether there is life on Mars or whether it could support life. Next, the Q-City mission discovered that methane levels on Mars vary significantly with the seasons. On Earth, methane is mostly produced by animal waste or the decay of organic matter. Therefore, methane is a powerful indicator of life. Of course, methane could also be produced geologically. Currently, researchers are actively studying where this methane comes from and whether it is produced geologically or by living organisms. Humans have sent dozens of Mars probes so far, but we have never found any signs of life or even traces of it. Why is there no life on Mars? First of all, it is very unlikely for Mars to be habitable. Its mass is only 1/10 that of Earth, and its gravity is only 1/3 that of Earth's. If a 70 kilograms person goes to Mars, their weight would become only 26 kilograms. Because of the weak gravity, Mars cannot hold on to its atmosphere, which gradually escapes into space. Second, Mars is much colder than Earth, and its magnetic field is very weak, only 1/80/100 of Earth's. With such a weak magnetic field, Mars cannot block the solar wind, which causes the atmosphere to disappear. As a result, there is hardly any air on Mars. Of course, Mars has some potential for becoming habitable, and we are actively researching whether there is any microbial life on the planet, or whether it could support life in the future. Earth-like, Mars has carbon dioxide and water vapor in its atmosphere, and even oxygen. However, the atmospheric pressure on the Martian surface is only about 0.006 times that of Earth's surface pressure, which is only 0.75%. With such thin air, it would be impossible for any living organism to survive. Compared to the Earth's environment, the Martian atmosphere is almost like a vacuum. This thin atmosphere also lowers the boiling point of water on Mars. The boiling point of water on Mars is only 27 degrees Celsius, so if humans were to be exposed to Mars's atmosphere, the water inside their bodies could be sucked out. It's really amazing. Another interesting fact is that the boiling point is the temperature at which the vapor pressure of a liquid equals the external pressure. If the external pressure decreases, the vapor pressure also decreases, so the boiling point decreases as well. In such an environment, even the most resilient organisms that are said to have high human survivability would find it very difficult to survive for an extended period of time. Mars also has extremely harsh temperatures. The average temperature on Mars is -80 degrees Celsius, and the surface temperature can drop as low as -140 degrees Celsius and rise up to 20 degrees Celsius. This temperature fluctuation is due to the thinness of the Martian atmosphere, which means that the molecules that make up the atmosphere are narrow and have less kinetic energy to maintain temperature and heat. This is why scientists have come to the conclusion that there is a very high likelihood that there is no life on Mars, as they have been studying the planet's physical characteristics since the 1960s when they began sending Mars exploration probes. Today's video discusses the process of exploring life on Mars by our Parliament, and why scientists have determined that the possibility of life on Mars is very low. However, there are some who still insist that humans must colonize Mars despite its harsh environment, and one such person is Elon Musk of SpaceX. If you are interested in astronomy and often watch movies about space, then you probably know the most important question that bothers enthusiasts of this topic. Are we alone in the universe? And no matter what anyone says, there is still no definitive answer to it. Despite the fact that the raw materials for life are everywhere and planets are abundant, there is not a single known world other than Earth that could confidently be called a home for life. However, there is hope that the search for the first signs of extraterrestrial life will be successful in the near future on exoplanets orbiting distant stars. There may be life. By measuring the spectral characteristics of their atmospheres using transit spectroscopy, or in the near future through direct imaging, we may be able to confirm this. But why look so far, when in fact, it's possible that it exists right here in our solar system? Mars, Titan, Europa, Enceladus, Ganymede, Pluto, there are plenty of candidates. Not long ago, on Venus, of all places, who would have thought phosphine was discovered? This exciting discovery is significant for science, chemistry, and the very question of life in the universe. In many ways, Venus is the most Earth-like planet in the solar system. With a comparable mass and radius, it could have been watery, moist, and equally conducive to life as Earth for hundreds of millions or even billions of years. However, today its surface is inhospitable and scorching, with a thick sulfuric acid-rich atmosphere. But nonetheless, it offers a wide potential for chemical processes. Phosphine, at first glance, may not seem like a remarkable molecule. Let's first recall the most abundant elements in the universe: hydrogen and helium, followed by oxygen, carbon, and nitrogen. These elements are formed in the previous generations of stars and are found in the atmospheres of rocky planets in our solar system. Systems, including Venus, Earth, and Mars, were dominated by these elements, likely containing significant amounts of water, methane, and ammonia. But it's not all that simple. For example, silane is analogous to methane, hydrogen sulfide shares many properties with water, and ammonia has many similarities with a spin. Here on Earth, silane is a colorless, easily flammable, and toxic gas. However, it is also naturally produced by anaerobic bacteria in conditions of oxygen deficiency. In a new study, a group of scientists from various fields came together to publish a series of 3 articles announcing an impressive discovery. In the upper layers of the hazy atmosphere of Venus, reaching its peak in the mid-latitudes, phosphine was detected. And this is not a mere assumption. Without a doubt, this radio signal was observed by 2 different observatories independently. They both observed the same absorption feature of equal strength at the same wavelength. Venus is a well-known natural emitter, and phosphine creates a distinctive dip in this emission due to its presence. This scientific discovery itself is very significant, but it tells us very little. Phosphine exists in the temperate zone of Venus, or in its vicinity. The temperature and atmospheric pressure are comparable to those found on the surface of the Earth, despite the hazy and dense atmosphere rich in sulfuric acid. The detected phosphine signal is strongest in the mid-latitudes, with a concentration of around 20 parts per billion, which is about 0.02% of Venus's atmosphere. Molecules in the Venusian atmosphere have many different wavelengths at which they can absorb light, which means that numerous different signatures can be observed. If we need to quantitatively assess the presence of this molecule's property in the Venusian atmosphere, currently there is only detection at one specific wavelength. However, if there are several other wavelengths observed, they will provide much more information. So far, the presence of phosphine has been established, but the next step will be understanding its origin there. For all of humanity in general, in our long history of space exploration, there is not so much a lack as a shortcoming that needs to be addressed. When an unexpected signature is unexpectedly discovered, an explanation that goes beyond our current understanding, the wildest conclusion is immediately drawn: extraterrestrial life. For example, about 40 years ago, carbon monoxide was discovered in the atmosphere of Titan, and its chemical composition could not explain this very signature. However, about 10 years later, the mystery was solved. It was found that Enceladus, an icy moon rich in geysers, was adding water to Titan's atmosphere. Since 2004, methane has also been detected on Mars, raising suspicions of the existence of something alive. But now, thanks to the Mars rover Curiosity, we know that methane exhibits a seasonal nature and even changes within a single day. Many are searching for a biological explanation, but in this case, a chemical origin seems more likely. We can also recall the mysterious star, Tabby's star, and the megastructures observed around it. Extraterrestrial megastructures are undoubtedly the most memorable headline, but there are many stars with peculiar dimming. Today, explanations involving these megastructures as alien constructions are considered far-fetched. It's not difficult to explain why we jump to such conclusions, but it takes time. And I believe that with time, it will pass. So it's better for us to return to Phosphine. The surface of Venus, like many other rocky bodies in our solar system, contains a large amount of phosphorus in the form of various phosphates. However, the conversion of these phosphates into phosphine is a complex task. One of the scientists working on this discovery, Dr. William Baines, described in detail 3 possible pathways for this conversion. Photochemical processes induced by solar radiation in the upper layers of Venus's atmosphere, chemical processes resulting from thermodynamic effects in the lower layers of the atmosphere, or geochemical processes resulting from chemical reactions on the surface. By using the most complex chemical modeling and considering a range of exotic scenarios, he found that none of these options fit. They all produced too little phosphine to explain the observed signal. And as you may have noticed, the scientist mentioned 3 options, but one is missing. Could phosphine be produced through a biological pathway? In fact, if we look at how phosphine is produced on Earth, it is exclusively through biological means. On Earth, it is a natural process carried out by bacteria in an anaerobic environment or artificially produced by humans. However, there is still much we don't know about its natural production, including which organism actually produces it. Presumably, a form of E. coli is involved in its biochemical pathway. Can this pathway be reproduced non-organically? Meanwhile, phosphine has been found abundantly throughout the universe in large quantities. It exists in the atmospheres of gas giants like Jupiter and Saturn, and it is found both as a standalone molecule and associated with other molecules around carbon-rich stars and even in the interstellar medium. But what is the reason for its appearance specifically on Venus? One thing can be said for sure: it is definitely related to an unknown chemical reaction. Some form of chemistry, in one way or another, produces these numerous phosphine molecules. This unknown chemical reaction could have one of several causes. It could be easily associated with a geological process, purely chemical, or even biological. In principle, it could be any of them, but still, betting on biology is like buying a lottery ticket and hoping to hit the jackpot. If life produces this phosphine, it must somehow survive by reacting with sulfuric acid, and it would require the microorganisms producing phosphine to be extremely abundant and efficient. They would need to occupy the entire volume of Venus's atmosphere in the moderate zone and work with almost maximum efficiency to account for this signal. It is not impossible, but it is a highly unusual scenario. So if phosphine is not a product of life on Venus, then the intriguing question arises: what is the actual source of phosphine? It cannot be produced in the same way as on Jupiter or Saturn, where its production depends on the strong pressure created by the dense hydrogen atmosphere. However, ruling out all possible chemical reactions is also not possible. What are the densities of different gases in Venus's atmosphere, depending on altitude and latitude? What is the distribution of phosphine? What are the precursor molecules or the molecules involved after its breakdown? And how the presence of various sulfur compounds, which exist in abundance in Venus's atmosphere, changes the reaction equations that we expect. There is still much we do not know about our neighboring planet, and only after answering these questions can we discuss the biological origin, that is, life. To understand the origin of phosphine, it will require not only new qualitative observations, but also additional missions to explore Venus. Perhaps that is the only way to reach the truth, and maybe that's why all this buzz was created. I intentionally didn't rush with a video on this topic, although I'm probably obligated to cover it on our channel. After all, it's practically one of the biggest events in cosmology this year. But the more I read about this subject, the more I thought that there have been relatively few missions to Venus. The near future was planned for Mars, Titan, Europa, Enceladus, and wherever else. Maybe it was necessary to pay more attention to Venus, but there simply wasn't a more successful alternative. But now, after the sensation with phosphine, you can see that things are already stirring up. There are missions planned for Venus. In general, agree that there is something to it. Even Dmitry Rogozin, the head of Roscosmos, referred to it as the Russian planet Venus. But returning to our topic, claims that phosphine is a sign of extraterrestrial life are at best wild speculative ideas, and at worst, simply fiction. It's an astonishing discovery, but it doesn't necessarily mean there is life on Venus.